Around 500 million years ago, Earth's oceans were home to a vast array of life forms, but all plants and animals remained confined to the seas. Over the next 140 million years, marine life underwent dramatic diversification, leading to the emergence of corals, sea urchins, and mollusks such as bivalves, which resemble modern clams, mussels, and scallops. The most significant development, however, was the rise of fish, the first vertebrates. These early fish started out as simple, jawless creatures, but the evolution of jaws was a game changer. It allowed fish to become active predators, enabling them to hunt in mid-water and along the seafloor. This evolutionary milestone triggered an explosion of diversity in marine ecosystems, giving rise to various species with different adaptations for survival. The earliest known fish fossils, such as Arundaspis from Australia, date back to the Ordovician period. These fish lacked jaws and teeth, instead using a round sucker-like mouth to feed. They had gills for underwater respiration and were likely slow-moving bottom feeders, scraping algae and organic material from the seafloor. Over time, many jawless fish developed heavy armor plating, likely as a defense against the growing number of marine predators. Species like Drepanaspas and Pteraspis had strong, bony head shields and thick body armor, offering protection from threats such as giant sea scorpions, some of the largest arthropods ever to exist, reaching lengths of over 2 meters. Despite their eventual decline, descendants of these early jawless fish, such as lampreys and hagfish, still survive today. With the arrival of the Silurian period, fish with jaws began to appear, marking a turning point in vertebrate evolution. One of the early jawed fish was Climaeus, which, like its jawless relatives, had a skeleton made entirely of cartilage rather than bone. Though bony fish would later become dominant, cartilaginous fish, such as sharks, rays, and their relatives, persisted and continue to thrive today. The development of jaws allowed fish to evolve into specialized predators, capable of seizing and devouring prey rather than merely filtering food from the water. During this time, invertebrates also flourished, with 3 groups from the Cambrian period becoming particularly diverse: trilobites, brachiopods, also known as lampshells, and graptolites. Graptolites, which were colonies of tiny marine animals, were incredibly common in Ordovician deposits and may have been related to early chordates, the group that includes vertebrates. Mollusks also advanced, with simple, limpet-like monoplacophorans evolving into bivalves and true snail-like gastropods. The emergence of cephalopods, intelligent, tentacled mollusks, further enriched marine ecosystems. Early cephalopods, such as nautiloids, had straight shells before evolving into coiled forms similar to today's nautilus. By the Devonian period, ammonites, a group of coiled cephalopods, had become expert predators, using their tentacles to capture smaller invertebrates and fish. The Devonian, often called the Age of Fishes, saw the greatest expansion of fish diversity. 2 main groups of bony fish emerged: ray-finned fish, Actinopterogians, and lobe-finned fish, Sarcopterogians. Ray-finned fish, which have thin, flexible fins supported by bony rays, eventually gave rise to the vast majority of modern fish species. Lobe-finned fish, on the other hand, had muscular, fleshy fins that contained bones resembling the limb structure of land vertebrates. This group included the ancestors of tetrapods, the first vertebrates to venture onto land. Among them were the Rhipidistions, which later evolved into the first amphibians. Some lobe-finned fish, such as the coelacanths, survived into the present day, providing a living link to this ancient past. Meanwhile, marine predators continued to grow in size and efficiency. The giant armored fish Dunkleosteus, which lived in the Devonian seas, was one of the first known apex predators. Measuring over 11 feet, 3.3 meters long, it had a powerful streamlined body and strong, bony jaws capable of crushing prey. Its sinuous movements, shiju, and eel-like tail, allowed it to hunt swiftly in open water, preying on smaller fish and invertebrates. Other marine creatures, such as massive sea scorpions, were formidable hunters as well. The presence of such predators may have driven the evolution of heavy body armor in early fish species, providing them with much-needed protection. As marine life continued to evolve, significant changes were also occurring on land. By the end of the Silurian period, simple land plants had appeared, forming the earliest terrestrial ecosystems. These plants laid the foundation for more complex vegetation, and in the Devonian, Earth saw the rise of the first forests, composed of tree ferns, giant horsetails, and primitive seed plants. These lush environments provided new opportunities for life to expand beyond the oceans. The first land animals, likely scorpions and millipedes, made their way onto shore, adapting to terrestrial life. Eventually, the descendants of lobe-finned fish, the first amphibians, followed, marking a crucial moment in evolutionary history. The transition from an ocean-dominated world to one teeming with life on land was a slow but profound process, driven by millions of years of adaptation. The rise of fish, the evolution of jaws, and the diversification of marine predators all played essential roles in shaping Earth's ecosystems. As plants and animals continued their gradual colonization of land, new evolutionary pathways opened, leading to the vast biodiversity we see today. The story of marine life's early expansion remains one of the most remarkable chapters in Earth's history, showcasing the resilience and adaptability of life through time. If you enjoyed this journey through time, be sure to like, subscribe, and hit the notification bell for more amazing science content. Thanks for watching, and see you next time.